In this video, we're going to take a look at Chapter 8, and you're going to want to look at this video before you attempt homework number 18. You're going to want to be sure to have your stats tables packet with you that I gave in class. Not only do you need your z-scores, but in addition, you're going to want to look at that very last page of the stats packet. It has 6 boxes on it that talks about the different types of hypothesis testing. In this video, we're going to be testing the claim about a proportion. In the next video, we'll look at testing claims about a mean. And this is what we call hypothesis testing. So the first thing I'm going to do is let's take a look at a question. It says a certain drug is used to treat asthma. In a clinical study of that drug, 223 people out of 260 people on the drug had a side effect of headaches, if you can sort of imagine that. There's been a claim made that this drug will only cause headaches in less than 12% of our subjects. We as statisticians are going to go ahead and test the claim that less than 12% of people who take this drug will in fact get headaches. All right, so how do we go about testing a claim? Okay, so the first thing I'm going to do is open up here the steps for how we test a claim. Now, the first thing we want to do is define our hypothesis. H sub 0 is your null hypothesis, and H sub 1 is your alternative hypothesis. And then we're going to identify which of those hypotheses is actually the claim. All right, so let's go back to our problem here. We'll close this down. And let's go right up here to, okay, so step 1. Let's go ahead and start with step 1. We're going to define our null hypothesis and our alternative hypothesis. And what you're going to notice on your tables is that the both of them are going to have the same value. The null hypothesis is always going to be an equality, and the alternative hypothesis will always be an inequality. We go to our claim to decide what that value will be. Here is the claim. Claim that less than 12%. So 12% is our claim. So our null hypothesis is going to be P equals 0.12. And in other words, our null hypothesis is that that claim is not true, that the drug does not have that side effect. It's either more than that or it's exactly that, okay? But the claim is stating that it's actually less than that. So this is our alternative hypothesis, that their claim is actually right here. And we want to define that. It's quite often the claim is the alternative hypothesis. Occasionally it will be your null. And the reason we want to define it is because it will help us with our conclusion at the end. Okay, what do we do next? Let's go back to our rules here. So let's see. Let me close this and open this. And it says here, step 2 is going to be to find p hat. All right, that's going to be our sample mean. So let's close this and open this back up. Oops. And we'll leave this open. Okay, so p hat. What is p hat? Well, we know that from before. That's going to be our sample percentage. Okay, so the study looked at 260 subjects, and out of those 260 subjects, 23 of them experienced headaches. So P in this case, we should probably define that. P equals the probability of having a headache for this problem. All right, and if you do that on your calculator, you will discover that P hat is 0.088. So 8.8% of our subjects experienced headaches in the sample that we looked at. Okay, what is step 3? Let's go back here. Step 3 says, determine the test type, draw a normal curve. We need to find the critical value, which is just a z-score, and we need to shade the critical space. Okay, I can do that. Let's go back to here. We are going to go over here. I'm going to change colors for this, and I'm going to draw myself a normal curve. Okay, guess not, because I won't change that. Here we go. All right, here we go. It's a normal curve, and we know that this is where our z-score is 0. This is the mean. This is where p equals 0.12. And what we need to do now is determine the critical space and the critical value. Well, we are given the critical space. It's this 0.01. That's the significance. And if you look at your table on the very back of your Stats Crunch packet, and I'm just going to close this and open this. Let's see, where was it? Right here. You are going to see that in this picture right here, because this is our null hypothesis, always an equality, but our alternative hypothesis is a less than. So we have what's called a left-tailed test. So we are over here. Our 1% is in the left tail. I'm just going to go ahead and draw this line. And this is our critical value. And our critical value is just a z-score. Okay. And we're going to look that up in just a minute, but this is the critical space, which I'm shading. And I know that that space there is 0.01. I'm going to add 2 extra zeros because you know your z table carries it out to 4 spaces. Now that is the area under the curve. So you need to go to your z table looking at the negative side because we're below the mean, and find that area under the curve that is as close to 0.0100 as you can find. And you will discover that your z-score is negative 2.33. And I'm not going to do that here because if you can't remember how to do that, go back and look at some of my earlier videos on how to use the z-table. Okay, so we have found our critical value and we have defined our critical space. All right, so let's go take a look at step 4. Step 4 says find the test statistic, which is also a z-score, and plot that on the curve. And they're giving us a formula for the finding that test statistic. And I won't get into exactly where that comes from right now, but we'll go over that in class. So here we go. Step 4 is finding that test statistic. And this is the most mathematical portion of our test. The test statistic, finding the test statistic, it's just a z-score. Z, or of our test statistic, is going to equal our sample probability minus p divided by the square root of p times q divided by n. Okay? So if we're plugging in those values, you can see from above that our p hat is 0.088 minus our p-value, which is 0.12. You can see right there that's going to be negative, which makes sense because we've got a left-tailed test, divided by p is 0.12. And if you remember, p plus q is always 1, so 1 minus that 0.12 is going to give us 0.88. That is q, divided by n, and in this case our sample size was 260 people that we looked at. And I'm going to go ahead and let you crunch that on your number. If you're on your calculators, if you're not getting the right value, please come see me. We'll make sure you know how to use your calculator correctly. But your calculator should spit out a value of minus 1.58. We'll go on to 156, but we'll just carry it out 3 spaces because that's how far we carry out z-scores. 2 decimal places. Okay, so where is that? Let's go ahead and plot that on my curve now. And if our z-score is 0 right here, then negative 1.58 is right about here. and you want to get in the habit of maybe getting another color or making a dotted line. You want to always be sure to distinguish between your critical value z-score and your test statistic z-score. They both are z-scores. And this is z equals minus 1.58. Okay? All right. What is that last step then? What do we do now? We're going to draw our conclusion. All right, that's what that's going to say. In the last step, we draw our conclusion. So what I'm going to do here now is go back to that spot where we had the, let's see, where did that, here it is. Okay, so this is on the last page of your table packet, and we're looking at a left tail test. So just to quickly go through how we analyze this. Here, this line here is your test, is your critical value, okay, that you've marked. And it says here, if the test statistic is in the critical space, then we reject the null. We reject the null hypothesis. And therefore, there's enough evidence to accept the claim that whatever that claim happens to be. If our test statistic is not in the critical space, meaning it's not in this red area, it's maybe over here in the green area, then we actually have to fail to reject the null. And there is not enough evidence to accept the claim. All right, so what does that mean for our particular problem? Let's go back here to our problem, and it says here that, oops, let's open up layer 3 question. Okay, so for this particular problem, we have our test statistic not in the critical space. It is not in this blue area. It is to the right of it. It is not in the critical space. So therefore, for this problem, we are going to, we have to fail to reject the null. And therefore, there is not enough evidence. In other words, we can't reject this null hypothesis. We can't cross it out. The only way to accept the alternatives is if we've proven, if we can somehow have enough justification to reject the null. In this case, we do not. There's not enough evidence to support the drug company's claim that less than 12% of patients or subjects or whatever word will experience headaches. Okay, and that is how you do a problem from homework number 18 and do a test a claim. It's very cool. We have tested that claim. We've failed to reject that null. We as statisticians could go back to the drug company and say you cannot make that claim. There's not enough evidence to support it. Okay, so now you can go ahead and try some problems in chapter 8, homework number 18. Good luck.